The Manufacturing Safety Alliance of BC is the not-for-profit health and safety association for manufacturers and food processors across the province. We invite you to call on us for confidential help with your safety program in response to COVID-19 or anytime, and visit our website for safety training and resources or information on the Occupational Safety Standard of Excellence, CORE certification enhanced for manufacturers and processors. Today's webinar is about hand sanitizer, and more than that, it's about safely managing process change in your plant. BC distilleries, craft breweries, and wineries have responded to pandemic shortages by shifting production capacity from liquor, wine, and beer to hand sanitizer. In many ways, they are ideally set up to make that change, but understanding the new hazards present in manufacturing a new product and implementing process changes to make that shift safely is a vital skill set. So today we'll learn a systematic approach to identify hazards, quantify risks, and develop controls, how to use a change management decision tree to identify concerns and ensure workers and assets are protected, and if you're making hand sanitizer or considering it, learn what you need to know to avoid the risk of explosion and serious injury. Our presenters today are Lauren Davies and Sheldon McKee. Lauren Davies is a Specialist Safety Advisor with the Manufacturing Safety Alliance of BC. He is a Canadian Registered Safety Professional with the BC RSP and has a diploma in Civil Engineering Technology. Lauren has had experience in the construction, mining, sawmill, and biofuel industries. Through working in these industries, he has gained process experience of fire protection systems, spark detection systems, and explosion protection systems. He also has experience in firefighting and mine rescue roles. He has been with the Alliance since 2016 as a safety advisor, combustible dust specialist. Sheldon McKee is an OHS safety advisor specialist with Manufacturing Safety Alliance of BC. Sheldon is a Canadian registered safety professional with the BC RSP and a registered construction safety officer with the ASTT BC. Additionally, Sheldon has a designation as Confined Space Entry Specialist from the National Association of Safety Professionals. At this point, I'll hand the presentation over to Lauren and Sheldon, beginning with Lauren.
Thank you, Anne. Sheldon and I would like to thank everyone for taking the time to attend this webinar. We have put this presentation together to protect our clients from process changes that they have not fully researched. An incident in Mumbai, India on April 13th, 2020 involved a cosmetic manufacturer changing over to manufacture hand sanitizer. As a result, on the first day of production, there was an explosion that was felt 5 kilometers away and resulted in the death of 2 workers. We would like to raise awareness so this type of incident is not repeated here. In order to fill the demand for hand sanitizer to protect from COVID-19 virus, many manufacturers have stepped up to fill the demand. Whenever a process is changed, it is important to reevaluate the hazards and controls to ensure the controls are still effective with the new process, and employees have been brought up to speed on any procedural changes. The following video is from the National Fire Protection Association, or the NFPA, and highlights some of the concerns around hand sanitizer products.
Everyone knows that alcohol burns. Bartenders have for years been lighting shots topped by high-proof liquors like 151 proof rum on fire. But did you know that the alcohol content in many popular hand sanitizing solutions is the same as it is in the high-proof liquors that allow these shots to burn so easily? Welcome to Learn Something New by NFPA Journal. In this episode, we're going to be diving into hand sanitizer and some of the safety considerations that should be taken into account when storing this flammable liquid, especially in large quantities. It's something NFPA has been fielding a number of inquiries on for the past few weeks, as the coronavirus pandemic continues to sweep the globe, and paper goods, cleaning supplies, and disinfectants, including hand sanitizer, have become hot commodities. First, you might be wondering, how flammable is hand sanitizer? To get an idea of any liquid's propensity to burn, you have to look at what's called the flash point. That's the temperature at which the liquid gives off enough vapor to ignite in air. A solution that's 70% ethanol or isopropanol, which is pretty standard for hand sanitizer, has a flash point of about 63 to 64 degrees Fahrenheit, below most room temperatures, meaning it only needs an ignition source, like a flame from a candle, to ignite. Here's Guy Colonna, Director of NFPA's Engineering Technical Services Division, with more.
The materials that you're talking about, these either ethanol or isopropanol are the two most common alcohols that are part of these alcohol-based hand rubs. They tend to have, as you said, a flash point somewhere in that 60 to 70 degree Fahrenheit, roughly maybe about 20 degrees Celsius. And so consequently, that puts them essentially right at room temperature, which means they don't need any external heat source to cause them to actually give off those vapors. Once those vapors concentrate in those right proportions of fuel vapors with the oxygen in the air, then the only thing that's missing in order to make them ignitable is a viable ignition source.
Now that you know this stuff is pretty flammable, you might be wondering, do I have to worry about using it? The answer simply is no. As public health experts from groups like the CDC have said, using an alcohol-based hand sanitizer is a suitable alternative to hand washing when protecting yourself from things like COVID-19, and that's way more important than worrying about your hands spontaneously combusting. The small amounts you would use, coupled with your warm skin temperature, means the liquid would evaporate quickly anyways, no longer posing a flammability threat. That said, storing hand sanitizer, especially in large quantities, does pose a fairly significant fire risk. Once you get into amounts over 5 gallons, your storage quantity would fall under the requirements of NFPA 30, Flammable and Combustible Liquids Code. The code outlines protection measures for safe storage of liquids like hand sanitizer, such as placing them in a flammable liquids cabinet or in an area protected by an automatic fire sprinkler system. What we're seeing during this pandemic is a lot of hand sanitizer being stored in places you might expect, like hospitals, but also in places that haven't traditionally stored such flammable liquids. A Tennessee man, for example, made headlines in March for having stockpiled almost 18,000 bottles of hand sanitizer, with the hope of price gouging buyers desperate for the product. We've also seen lots of breweries and distilleries across the country convert their production facilities from making booze to making hand sanitizer. While these facilities are accustomed to storing alcohol-based solutions, they typically aren't storing solutions with as high of a percentage of alcohol as hand sanitizer. Again, here's Guy with an overview of a concept known as change management.
They may have introduced things that compromise previously put in place protections. And in the chemical processing world, in terms of safety processes and safety management and things like that, there's a term called change management. And what that in essence says is that anytime you're going to change the equipment, or you're going to change the materials that you're using, or change the processes, or change the protection strategies that you have, you should go back and reevaluate your original strategy to see that if what you're going to be doing new hasn't compromised those things in an unintended way.
Well, that's it for this month's episode. If you're looking for more content on fire, life, and electrical safety as it relates to the coronavirus pandemic, visit nfpa.org/coronavirus, where you'll find an extensive collection of blogs, fact sheets, white papers, videos, and podcasts. That link is in the description of this video, as well as a link to a blog post that includes my full interview with Guy Colonna. Thanks for watching. If you like these Learn Something New videos, let us know by leaving a comment or liking the video. Be sure to share it with your friends and subscribe to NFPA's YouTube channel for more content like this.
Well, thank you. So just to review, according to the NFPA, if you're storing more than 5 gallons of hand sanitizer on site, it requires that you follow the guidelines set out in NFPA 30, and that's just so that you're aware. To protect our employees, we have to follow a systematic approach to identify the hazards, quantify the risks, and develop the controls to mitigate those hazards. We have developed a change management decision tree chart to help you identify areas of concern to ensure that employees and assets are protected. If you follow the decision tree process, you can adapt it for future changes. Following the strategy will build a strong understanding of the hazards associated with the process and the controls and training that require implementation before the process change takes place. This will protect your employees from any injury and company assets from property damage and financial loss. We have developed a change management decision tree chart to help identify areas of concern to ensure that employees and assets are protected. The following strategy ensures process safety risks are identified. The tool we're using today is called a process decision tree. It is your tool to ensure that you've identified the hazards present in your specific process. I'll pass this on to Sheldon McKee to explain the graphic.
Thank you, Lauren. Please understand this chart is a planning tool to help identify the possible hazards and ensure the controls will be sufficient to prevent injury and property loss. Using this chart as a guiding tool, it will improve your regulatory compliance and proof of due diligence. The slide that you see is just to give you an overview of what the chart looks like. We will be covering each step in detail. If you didn't get a chart emailed to you when you registered, please email us and one will be sent to you. There are 11 steps in total. Each of these steps have a red border. These steps are to assist you in the process and do not have to be completed in order, just as long as you have completed these steps. You may have already completed some of these steps. Beside each step is a decision and information box. These have a blue border. Within these boxes, the standards and regulations are referenced. In between these boxes are diamonds. These are decision boxes. Inside these diamonds is an I in a blue box. This is for information. These have been merged to indicate a decision and information. MSABC has provided many references in this presentation. However, the manufacturer needs to take responsibility of researching other resources that will be unique to their process and chemicals used. Remember that it is the employer's responsibility to ensure a safe workplace. I will pass this off to Lauren.
Thanks, Sheldon. It's very important to systematically go through the process so there are no surprises. For instance, using an acid solution to clean a galvanized equipment can produce hydrogen, a flammable and explosive gas. Whenever a change of process is considered, it's vital to understand the characteristics of the materials involved. Minor changes in concentration, reactivity, or flammability can have large impacts on the employees and the company assets. Include the chemicals used to sanitize after the process is complete in this evaluation to ensure there is no adverse reactions. For example, using a process that creates ethanol at 20%, the flash point where flammable vapors will be given off will be 25 degrees C. Raising the ethanol content to 100% will decrease the flash point to 13 degrees C. A small increase in ethanol percentage can lower the flash point to room temperature, risking a serious fire. Now that you know the products involved in the new process, the next step is to collect the SDS, or the safety data sheet, for the specific chemicals that you plan on using. You will need to clearly understand the flammability, reactivity, spill procedures, first aid measures, and health effects of each product in the process. You can find this information on the SDS sheet for each product. Ensure that the SDS is for the same product and for the same concentration that you are using. If you have any questions regarding WMIS 215, we have free courses on our online learning center that should help you understand the requirements and how to access the information. Now that you've got the safe handling and emergency response requirements for your products, the next step is to ensure the emergency response equipment, training, and procedures implemented at the workplace align with the new process. I'll pass this on to Sheldon.
Thank you, Lauren. Let's talk about eye wash and shower requirements. For example, a company has purchased a solution of hydrogen peroxide. The SDS specifies that in the event of skin or eye contact, the area should be flushed for 45 minutes continuously. Will your eye wash station or shower station be able to handle this requirement? The average hot water tank will be consumed within minutes, leaving the person exposed to a cold water for the duration of the flush cycle. This is a serious issue when using the shower, as this can induce a state of hypothermia. A proper system will require a rated water heater for the purpose, or alternatively, a tepid inline water heater that will provide a continuous supply of warm water. The above pictures is a small representation of what is available. Do you have adequate fire extinguishing equipment to respond to an alcohol-based fire? For instance, an employee is mixing a small tank of 50% alcohol solution with an electric hand drill. The sparks from the drill's commutator and brushes is a strong source of ignition. If a fire resolves, is your employee trained in the use of the fire equipment? Are there other flammables in the area that will add to the fire intensity? In the event of a hand sanitizer fire, the following types of substances are recommended to extinguish the fire: alcohol foam, CO2, or dry chemical extinguisher for type B flammable liquids. During the handling and manufacturing process, it is quite reasonable to expect spills. After reviewing the chemicals SDS, here are some things to consider. Are chemicals environmentally safe, or will they cause environmental damage if they escape to a waterway through a drain? If spilled chemicals migrate to floor drains, will these drains carry the chemicals to other areas of your facility? Do you have a spill response equipment and a plan in place to contain the spill? Is the spill kit sufficient for a larger spill? This will be based on the volume of the product manufactured. Let's say you're handling and or mixing 500 liters at a time. Will the current spill kit be sufficient? Once the spill is contained and cleaned up, are there procedures and processes in place to safely dispose of the contaminated material? Are your staff trained in the use of the spill kits and how to replenish the kits? Depending on the volume and process, the spill response can be simple to complex. An assessment needs to be conducted to assure an appropriate spill response, procedures, and equipment are present. I will pass this on to Lauren.
Thanks, Sheldon. The next step is, are materials created on site, for instance, distilling ethanol, or are they purchased and brought to site in containers? And for example, this could be isopropyl alcohol or hydrogen peroxide. The transportation of products is critical to process safety. Containers can be dropped or broken during loading and unloading. Vapors can be released when liquid is being transferred from one container to another, creating the risk of ignition from unprotected ignition sources in non-process areas. Whenever flammable liquids are open to the atmosphere, vapors are released in varying amounts. Environmental variables such as humidity, temperature, and ventilation will determine if vapors will form an ignitable mixture. For reference on that, see NFPA 30 flammable liquids. For your reference, the lower flammable limit for ethanol is 3%. The transfer of flammable liquids from one stage of the process to another is an element that needs serious consideration to ensure that alcohol vapors do not reach ignitable concentrations. Consideration should be given to minimize the creation of static electricity as a result of product transfer. Again, I'd like you to take a look at NFPA 30 if you have any questions around this. The transfer of flammable liquids adds new ignition risks, static electricity, to your list of concerns. Do you have an electrically safe ventilation system or large ambient natural ventilation control? Again, we want to see the NFPA 70, which is the electrical code, Article 500, electrical hazard classification, for any questions in this area. Is the electrical equipment in the area of vapor generation designed for flammable vapors? And this is the same reference earlier for your electrical hazard classification. Even storage of alcohol in wooden barrels allows alcohol vapors to escape. In distilling, this is called the angel share. Improper storage and lack of ventilation can lead to flammable atmospheres being developed. I'll pass this back to Sheldon.
Thanks, Lauren. Failure to identify potential ignition sources can lead to catastrophic consequences. This is a critical step. You must evaluate two areas of possible ignition sources. One, ignition sources internal to the process, and number two, ignition sources external to the process. It is important to understand there must be rigid ignition control in the immediate area. No hot work such as welding or grinding or operation of electrical equipment that is not electrically safe. The above illustration shows grounding and bonding. The small canister is bonded to the larger one. The canister is grounded. This process allows for both containers to have the same electrical charge. A spark only occurs when there's a difference of electrical energy. All containers should be bonded and grounded. When transferring flammable liquids, electrons can be exchanged between materials in contact. Materials with a weakly bound electrons tend to lose them, while materials with sparsely filled outer shells tend to gain them. This is known as triboelectric effect and results in one material becoming positively charged and the other negatively charged. A spark potential is created. With this in mind, do you have a grounding and bonding program established to minimize static electricity ignition risk? In the manufacturing process, we need to transfer and mix fluids to make the hand sanitizer. During this process, transferring and handling fluids creates various levels of turbulence. Is there a process developed to minimize the turbulence? The action of the turbulence assists in liberating larger amounts of vapors. Every effort should be made to minimize product turbulence while transferring and handling. Using tools like a hand drill to mix fluids will create vapors potentially to be ignited. Manual mixing will also generate vapors that may migrate to potential sources of ignition. Ensure the electrical equipment, extension cords in the area meet the electrical code requirements for flammable vapor hazards. An often overlooked source of electrical ignition is mobile equipment. Mobile equipment have multiple ignition sources. It is important to evaluate your mobile equipment prior to the use of the process in the area. Every workplace has lighting. Ensure the lighting in the area meets electrical code requirements for flammable vapor hazards. For example, if you have halogen lamps. For proper operation, these lamps run at a much higher temperature than regular incandescent lamps. Because of the very high temperatures, halogen lamps can pose a fire and burn hazard. To quantify this, a 300-watt tubular halogen-operated bulb at full power quickly reaches temperature of about 540 degrees Celsius. That's about 1004 degrees Fahrenheit. The ignition temperature for ethanol is 363 degrees Celsius, or 685 degrees Fahrenheit at a 100% solution. When you're diluting the solution, the temperature will increase. I will pass on to Lauren now.
Thanks, Sheldon. Next on our list is process monitoring. Are there systems in place to alarm before flammable levels reach the lower flammable limit in case of a process upset condition? On your screen, we have some examples of monitors that will detect ethanol. There's three here. On the left, there's a stationary monitor, which is a ENMET18 channel controller. In the middle, we have a stationary Millennium infrared gas detector. And on the right, we have a portable Draeger PAC 800OV personal monitor. The processes should have vapor detecting systems to monitor processes in an area where vapors have potential to be released, to alert workers before hazardous levels occur. This next table is an interesting one. It compares the common flammable liquids. You'll notice that alcohols are in the same NFPA classification as gasoline. I would also like to bring to your attention the minimum ignition energy for ethanol is only 0.23 millijoules. To put this in context, closing a household switch on a 10 amp circuit will generate a spark energy of 0.5 millijoules at the switch. In addition, a person walking on a nylon carpet can generate a spark energy of 25 millijoules. You can see it does not take much to ignite flammable vapors such as ethanol. A few other things I'd like to bring to your attention is the specific gravity of alcohol vapor is 1.601, and the ignition temperature to ignite alcohol vapor is 363 degrees if it's at 100% alcohol. The SDS for chemical will specify the appropriate controls to eliminate or reduce exposure. Sometimes it will require an exposure control plan. If the specific chemical requires it, develop an exposure control plan, or ECP, specific to the process and materials to control the exposure. For example, hydrogen peroxide chemical burns. If you're having difficulty developing an ECP, contact MSABC for assistance. I'll pass this back to Sheldon.
Thank you, Lauren. When manufacturing hand sanitizer, it is important to review the existing PPE to ensure it meets requirements. For example, if there are flammable vapors generated as a result of the manufacturing process, do employees require flame-resistant clothing and specific PPE in order to reduce the injury should a flash fire occur? As you can see, there are a variety of flame-resistant or FR-rated clothing available. Research the flame-resistant clothing required, and if this type of clothing is required, ensure to select the correct clothing for your application. In this assessment, consideration of underwear is very important. Flammable fumes can migrate past outer clothing, and in the event of a flash, synthetic underwear can fuse to the body. This makes for a very painful injury and recovery process. There are other lower levels of FR-rated materials, and these are 100% cotton, 100% wool, and 100% silk. It is important to ensure these alternatives are adequate for the processes and will provide the required protection. Be careful of the blends. Ensure eye protection. Face shields and balaclavas are rated for flash and flame-resistant flame incidences. Additionally, ensure gloves and accessory garments will protect against all routes of entry. I will pass this on to Lauren.
Thanks, Sheldon. We also have to consider storage. How much flammable product will have to be stored to feed the process? How much finished product will have to be stored waiting for delivery to consumer? At what point do additional controls and procedures need to be implemented? For this information, I'd like to reference you to NFPA 30. The next thing I'd like to bring to your attention is to consult the fire codes on allowable storage volumes of flammable or combustible materials to ensure you are in compliance. For additional information, NFPA 30 for alcohol-based products or NFPA 432 for hydrogen peroxide-based materials regarding storage practices. Remember, alcohol-based hand sanitizer products should not be stored or should be stored in secure locations that do not experience extremely hot temperatures. I'd also like to point out that hydrogen peroxide is also temperature sensitive and will experience explosive thermal decomposition if allowed to reach 150.2 degrees C. Consider the final product combustibility or flammability in conjunction with the fire codes and municipal bylaws on storage requirements for intended finished product storage volumes. Again, we have NFPA 30, 432 for hydrogen peroxide, and the BC Fire Code, Part 4, Division B, 4.2.9, Rooms for Storage and Dispensing. Our next step is to assess the training component. What additional training will be required to educate employees on the hazards present and the actions required in the new manufacturing process? What changes will be required in emergency responses for fire, first aid, spill response, and evacuation procedures to ensure they are effective? I'll pass this back to Sheldon.
Thank you, Lauren. Do you have confined spaces on your site? Have you conducted a confined space initial determination to verify? If you have purchased a new tank and it meets the confined space definition, have you had a qualified person come and develop a hazard assessment and an entry plan? Has a rescue plan been developed? Is a permit needed to enter? If you haven't had one, a person come in and do the assessment, MSABC can assist you with this. For existing tanks that are converted for a new purpose, The pre-existing use and condition needs to be considered. Will it be compatible with the new use? Additionally, has a new hazard assessment that is space and task specific been conducted with a new entry plan and rescue plan? If there is worker entry for cleaning or inspection processes, does the hazard assessment reflect the additional hazard present when cleaning tanks that could have flammable vapors and gel residues from the hand sanitizer production? Will gaskets or seals be compatible with the new recipe of chemicals? Has an assessment been completed to ascertain if fugitive vapors can potentially migrate into adjacent confined spaces or areas of restriction? As Lauren mentioned earlier, the specific gravity of alcohol vapor is 1.601, thus being heavier than air. Be aware of low-lying spaces within your facility collecting alcohol vapors. And finally, now that you have made your hand sanitizer, it just can't go out the door yet. So we need to know, have you developed an employer-supplier SDS as required under the BC OH&S regulation and WMIS 2015 legislation? When an employer produces a hazardous product in the workplace, the employer must prepare an SDS in respect of that product that discloses the information required under the hazardous product regulations. Now back to Lauren.
Thanks, Sheldon. In summary, small changes to a process can have far-reaching effects. Analyzing changes should follow a systematic process to ensure that the existing controls will be effective at maintaining process safety. If they need to be upgraded, then additional safeguards, training, and communication will need to be implemented prior to implementing the new process. I have hoped we've raised your awareness and given you a new strategy to deal with process changes. I would also like to mention that this presentation is being created to raise awareness of some of the issues involved with the production of hand sanitizer and is not intended to be an exhaustive study of a particular process.
Thank you, Lauren and Sheldon, for such an informative presentation. We have some questions beginning to come in from the audience. To all of you, if you have questions, please submit them through the chat window. And if you would like individual help with your safety questions, please call or email us for assistance. We're reaching out to all our member companies over the next couple of weeks to check in with you. Take advantage of our support to keep your people safe. So to start the Q&A, Lauren, I have a question here. I've already made hand sanitizer and I haven't had any issues. Do I need to be concerned?
Yes, this is the whole reason for this presentation. The ignition risks are very susceptible to multiple variables. So as a result, you can do things in an unsafe manner for many times before you will be caught. So it's very important to take a close look and ensure that you understand the flammabilities of the product you're using and review your procedures to make sure they're safe. Just because you didn't get burned today doesn't mean it won't happen tomorrow. So again, you need to be really careful with this stuff. If I was telling you you were working with gasoline, you'd be a lot more cautious.
Thank you. So if alcohol is so dangerous, why have we not had more incidents? Lauren?
Well, this is a good question, and I understand why we are so complacent with alcohol, because we are quite familiar with alcohol for centuries. The key part is that most of the companies are familiar with using alcohol in lower concentrations, whether this is 5 to 20%, which is your normal fermentation range, or even in the lower levels of distillation. What we're talking about with hand sanitizer is products that are 60 to 90% alcohol, and as a result, the flammability is substantially higher.
Okay, another question. What are the guidelines for making your own hand sanitizer? As an essential service, we have had to resort to making our own at times due to the shortage of sanitizer. Sheldon?
Hi. Pretty much the process we just described is the guideline. So you just can't stop, whip them up, and then carry on. You should follow this process, the guidelines we just presented to you today, in order to safely and be compliant in making your own hand sanitizer.
Great. I have another one here. I've been asked to source plastic bottles with pumps of all sizes from 60 milliliters to 1 liter bottles from Asia. Is there a shortage of such bottles that you're observing and hearing from sanitizer producers, either pre-existing or newly pivoted?
I'll answer this one, but to my knowledge, we haven't had any concerns around shortage of bottles. So that might be something that might be coming up, but to this point, we haven't had any concerns that way.
I can also add to that. I have been doing some research on the website, and I came across one website called consumerreport.org, and they paneled a lot of suppliers and that, and people who are making hand sanitizers, and yes, they're starting to have a difficulty in getting the containers. So, when we have an increased need for the sanitizer, we need the increase for the containers. So now the plastic bottle manufacturers are having a difficult time to keep up. We can see probably in the near future there will be a bit of a issue with that.
Okay, so why are eye wash and showers such a concern? This presentation includes hydrogen peroxide, which can be very caustic in higher concentrations.
Yes, one of the things that we are all familiar with is hydrogen peroxide. A lot of us have it in our first aid kits, but we don't realize that the concentration that we use in our first aid kits is in the neighborhood of 1 or 2%. When we start increasing the concentration, it becomes very, very caustic and can lead to serious burns.
Okay. Is there any special size of cable or wire needed for grounding and bonding?
I'll take this one. No, there isn't. If you follow the NFPA 77 Annex G, they have a guideline in there that tells you what they expect what size of cabling and how to hook it up and the configuration. Yeah, we need to be careful of if it's a permanent fixture or if it's going to be disconnected and connected a lot, which will then dictate what kind of wiring is going to be used. Size-wise, that will have to be referenced through the NFPA 77 to see what it is. Generally, it's not a very big wire, but if it's hooked up to a piece of equipment that vibrates a lot, you will want it a braided wire. If it's a stationary object where it sits, you can use a regular wire, insulated or uninsulated, but the NFPA 77 prefers uninsulated wire is preferred because they want it for inspection purposes, so you can see if there's any damage or anything like that can happen to it.
All right, thanks, Sheldon. I have another one here. Our owner wants to start producing hand sanitizer as soon as possible with isopropyl? I can't pronounce that. What are the legal requirements other than the SDS sheet?
Well, the big thing is if you're doing this in a hurry, the concern is the concentration of alcohol vapors. And if you had to do it in a hurry, depending on how you planned on mixing it, I would recommend doing it outside.
Fair. Okay, I have another one. Are you allowed, for example, is it safe to store 1,000-liter tote of NGS 96% alcohol in a C-can shipping container?
Ooh. That's not a great idea, but it's you're going to be something that shipping container has to have ventilation to allow the alcohol fumes to leave the container. So it definitely has to have some venting, and it can't have any electrical sources of ignition in there if it's in a container as well. So a simple light switch would ignite that if there's any leak.
Can I add to that there, Lauren?
Go ahead.
Also, the container it's in is considered the primary containment. The C-can can be considered a secondary containment only if you can assure that if there was damage to the primary container, that it would contain any leakage. If not, you would have to have that container in a secondary containment, which would be then stored inside the C-can.
Okay. So, Sheldon, what variations of FR clothing are there?
There are 4 variations. Now remember, it's just when they say FR clothing, everybody thinks of oil and gas or heavy industrial, this sort of thing. In this situation, you don't need that kind of clothing, the same as what the firefighters wear or anything like that. But what they're made from is what you're going to have to consider. So there's what they call inherently FR fibers. These are defined as flame resistant as an essential characteristic of the fiber. Okay. Then there's treated fabrics where they're normal fabric, cotton fabrics, they're treated with a chemical. And then we have treated fibers, which is the same process but more deeply integrated. And then we have blends. So you want to take a look at that to see what one will work the best. But what I want to stress is that even if you are wearing FR rated clothing and you spill any of the ethanol, alcohol, isopropanol on there, anything like that, it will affect the flammability. What it means, the FR rating is no longer there. You must change that piece of clothing. Otherwise, it will still burn and you can then suffer heat transfer burns to your skin. So it's recommended under the NFPA that 2113 and 2112 that the minute that you get soaked with this or splashed on your clothing, change that piece of clothing.
Thanks, Sheldon. I have another one here. Do delivery staff need to get specialized training to transport hand sanitizer? Lauren?
Not if you're, excuse me, not if you're talking about consumer-sized packages. As soon as you transport more than that, then you're in the TDG rules, in which case they do. So as long as you're just transferring like a box of hand sanitizer, you'll be okay. But if you're actually looking at loading a truck with hand sanitizer, then you need to have your TDG information.
Okay. Thanks, Lauren. If we simply cut 99% of someone has to teach me how to say this word,
isopropyl. Yeah.
Isopropyl to 70%. Let me repeat that. If we simply cut 99% isopropyl to 70%, do we require a new SDS to be formulated?
Yes.
That was short and sweet. Another question. Can I import and store large jugs of ethanol to supply to hand sanitizer manufacturers? That's the first part.
You can.
Okay.
We can all import whatever we like. It's the matter of once you store it on your property, then do you have the appropriate safeguards in place to allow it to be stored there?
In addition to that, do I need any special permits and licenses to clear customs to store and to do the transport? Are there any requirements for where I can store these?
Your local fire department will have a list of requirements for you, depending on your area of the province that you're in, or whether you're on a federal site or whether you're on a provincial site. So you should consult your local authority to make sure that you have the proper spots in place.
Okay, this is more a comment and not a question, but in addition to the hazards of skin contact, hydrogen peroxide will also decompose to hydrogen and oxygen, so you need to be careful about piping design to avoid pipe rupture, and you need to be aware of explosive levels of hydrogen accumulation.
This is very correct, and this is one of the reasons why we're so concerned about people using hydrogen peroxide without having fundamental knowledge. Hydrogen peroxide, we think of it as a common household solvent, but in actual fact, it's also used for explosives and for rocket propulsion. So using it in high concentrations brings on a lot of extra hazard.
Fair. All right. Do you need any government numbers to sell hand sanitizer?
Good question. Don't know.
We'll have to check on that one. Normally, you need to have your SDS in place before you pass it on to someone. But as far as having a government approval, I'll have to check into that one.
Okay.
If I may, Anne, if I can
Sure.
back up a bit. Someone asked about the customs bringing in large amounts of stuff to store, alcohol to store and that sort of thing. On the chart, we've referenced a lot of different fire codes and things in that. If you refer to them, and if you go to the finished product storage section of 8B and the chart that we supplied, it's referenced BC Fire Code Part 4, Division B4.2.9. It says rooms for storage and dispensing. So there's within that code, the BC Fire Code, which you can get online and see for free. This will tell you what you need to do when you're going to be storing these kind of products, and also consult your insurance company and the municipal city hall to see what kind of requirements they may have. with those all in conjunction, you will know exactly what you need to do if you're going to store this large amount of type of chemical.
I think you just answered the next question that had come in during that time. Basically,
okay.
It was just to share the question. How can I prepare my warehouse to store these new raw materials used for hand sanitizer?
And the best answer for this is actually NFPA 30. That'll give you specific procedures on how to store chemicals, how deep, how far the rows should be apart. And most of those will be either referenced or duplicated in your local fire code.
Thanks, Lauren. So can I get electrical equipment that does not spark, Sheldon?
Yes, you can. It's called brushless types. They're what also referred to as digital motors. And you can get like Milwaukee, Bosch, and these kind of things where you can get drills that you won't, they won't have a brush in them in the commutator, this sort of thing. Because what happens is the commutator gets worn and the brushes get worn, they start to bounce and they create a spark. So you can either get a brushless or you can get what they call is an enclosed type electrical tool like a drill where the brushes and the commutator are enclosed. I still don't like those types because the problem is that you can still get a risk of vapor in that tool, whereas if it's brushless, you have zero worries about that sort of thing. And you can get that in all different kinds of equipment too.
Okay, we just had a note from WorkSafe BC. Just wanted to say hi. Yes, you need Health Canada approval to sell sanitizer.
There we go.
Well, thank you for that.
Yeah, appreciate it.
At this point, I just want to thank everyone for their questions. If we missed yours, watch for answers on our COVID-19 frequently asked questions page or call us to talk with a safety advisor. And just want to thank everyone very much for joining us today.